Hey folks, welcome back. In this video we're going to go over 3 worked examples to show you how to do problems involving the energy and frequency of a photon. Now if you haven't already done so, check out my previous video covering the theory on this topic, and that way you can apply what you learned in that video to this one. So let's get started. Question 1a says, what happens to the energy of a photon of electromagnetic radiation as its frequency increases? Well, remember we saw in the theory video that as frequency increases, the energy of a photon increases, since from the equation E equals hf we have that the energy is directly proportional to the frequency. Part B then says to sketch a graph to show this relationship. Well, if you sketch a graph, it should look something like this, where you've got photon energy on the y-axis against frequency on the x-axis. And to show this directly proportional relationship, we need to have a straight line going through the origin. And lastly, part C says which physical quantity is given by the gradient of this graph. Well, remember the equation relating these two variables is E equals hf, where h is Planck's constant. And if we plot E, the photon energy on the y-axis, and f, the frequency of the photon on the x-axis, then if we compare E equals hf to the equation for a straight line, y equals mx plus c, there would be no c in this case, no y-axis intercept, but if our y-axis was E and our x-axis was f, then that leaves the gradient of the straight line being h, Planck's constant. So we can say that the gradient of the line on this graph would give you Planck's constant h. Question 2 says a photon has a frequency of 6.4 times 10 to the 14 Hz. Calculate the energy of the photon. Well, writing down we know from the question we're trying to find the energy E. We know that Planck's constant h is 6.63 times 10 to the minus 34 joule seconds, and remember that's on the data sheet. And then the frequency f is 6.4 times 10 to the 14 Hz. So writing down the equation relating energy, Planck's constant and frequency, we have E equals hf, substituting in the numbers gives 6.63 times 10 to the minus 34 times 6.4 times 10 to the 14, and if you put that into your calculator you should get an answer of 4.2 times 10 to the minus 19 joules. Now it's worth pointing out that when you're doing questions involving the energy of a photon and the frequency of a photon, you should be getting very small energy values of the order of about 10 to the minus 19 or 10 to the minus 18 or 10 to the minus 20 joules, whereas the frequency values that you use should typically be around 10 to the power of 14 or 10 to the power of 15 Hz. Lastly, question 3 says a photon of orange light has an energy of 3.32 times 10 to the minus 19 joules. Calculate the frequency of the photon. So writing down what we know from the question, we're trying to find f. We know the energy E is 3.32 times 10 to the minus 19 joules, and Planck's constant h from the datasheet is 6.63 times 10 to the minus 34 joule seconds. So writing down our equation again, we have E equals hf. Substituting in the numbers gives us 3.32 times 10 to the minus 19 is equal to 6.63 times 10 to the minus 34 times f. And to get f on its own, we want to divide both sides by Planck's constant here, and if you do that in your calculator, you should get an answer of f equals 5.0 times 10 to the 14 Hz. That's all for this video folks, thanks for watching. If you made it to the end, I really appreciate it. Make sure to give the video a like, subscribe to the channel, and I'll see you in the next one. Take care.